This is PreCalculus Unit 7.3. Here's where we left off last time. We were solving systems of equations using invertible matrices. And then we're solving the matrix equation x equals A inverse B. Alright? Before we get to the next example, which is a nice application, one of my favorite ones, let's talk about the graphing calculator instructions. Alright, we want to be able to use the graphing calculator to help us solve some of these matrix problems. So let me bring up the graphing calculator. Here we are. So, let's go back to example 2 and see if we can plug in the coefficient matrix into the graphing calculator. I'm going to press second and then that x to the negative first where it says matrix. And here I have a list of matrices that are empty. And I'm going to scroll to edit. Press enter on matrix A. Let's make it a 2 by 2 matrix. And now I can enter 4 different values. If you look to the left, my matrix of coefficients is 2, 3, negative 3, negative 7. That is now my matrix A. If I quit out of this and then press second matrix again, now you can see that matrix A is a 2 by 2. Press enter, and we have 2, 3, negative 3, negative 7. But remember, our first step in example 2 was to find the inverse. Now, I'm going to press second matrix and then A again. But in order to find the inverse, you cannot press caret negative 1. Instead, the matrix button says x to the negative first. So if I press that instead, and now enter, I get the inverse matrix. So all of that solving and row operations used to shift the identity matrix over to the left can be actually done by the calculator. Remember, we like to do things the hard way first, and then use the graphing calculator because it's nice. So now, recall that our B matrix is the matrix of constants. 25, negative 25, and 60. So let me enter and edit matrix B. Let's make it a 2 by 1 in which the first entry is negative 25 and the second is 60. Go back to the regular screen and let's type in A inverse B. A inverse B. Let's see what happens. And we got our solution to the system. There are tremendous applications of linear algebra. One of them includes finances. We want to find the optimal portfolio of a series of investments. So, suppose that you have $50,000 to invest and you want to spread the amount between bonds, stocks, and exchange-traded funds. Since stocks are a risky investment, you can make money, but you can also lose more money. You want to invest more of it in the bonds. So let's put 4 times as much money in bonds as in stocks. Assume that typically a bond will return 2% per year, an exchange-traded fund return 5% per year, and stocks return 10% per year. Over the course of a year, you want to earn $2,150 per year in interest. Write a system of equations that models the investments. So the first one, our investments in stocks, bonds, and ETFs should equal 50,000. Just the way that it's mentioned first, bonds, stocks, ETFs, let's let bonds be X, stocks be Y, ETFs Z. Then it says you want to invest 4 times as much in bonds as in stocks. That means that the amount of money in bonds should be equal to 4 times the amount in stocks. And then assume that the bonds return 2%. So you're going to get 2% of your money in returns on the bonds, 10% on stocks, and 5% on ETFs. All told, you want to make $2,150 per year. There's a set of 3 equations. However, in order for us to put it in the calculator, remember we need a matrix of coefficients. That means the second equation, we have to change that to x minus 4y equals 0. Okay, 3 different equations. Now below, we have written instructions for example 3. Let's press second inverse, scroll to edit, and then we're going to make A. This time, we're going to make it a 3 by 3. Okay, before we go through the rest of the video, consider pausing it and try and follow all of the steps, 1, 2, 3, 4, 5, 6, 7, 8, and see if you can come up with the answer to the amount of money you should have in each investment. All right, let's continue. We'll do the whole thing step by step. So X, Y, Z adds up to 50,000. X minus, let's make it a negative 4, and then there's no dependency on the ETFs. And then the last one, 0.2% on the bonds, 0.1%, 10% on the stocks, and 5% on the ETFs. So there's our matrix of coefficients. I'm on number 3 now. Number 4, let's press second matrix, edit, and let's fill in matrix B and make that the constants. Enter the dimensions for matrix B as a 3 by 1. Recall that AX equals B, then X equals A inverse B. Our constant matrix, 50,000, 0, 2150. So now I'm on number 7. Let's find A inverse. Second matrix A, enter, and then press that inverse button. That little gem right there is a lot of work to find an inverse without a calculator. But here we have it, nice and easy. And now, step 8, let's find A inverse, and then multiplied with matrix B. Ah, it comes out so nicely. All told, we have the amount of money in stocks is $20,000. The amount of money in bonds is $20,000. The amount of money in stocks is 1/4 of that amount. And the amount of money in ETFs is whatever's left over. Perfect amount of investments that should be optimized so that it will return us $2,150 every year, and you've got 4 times more money in a much safer asset in bonds than in stocks. That is all. Please comment on this video in order to earn credit, and then have a nice day.